Let us continue atomic structure. In that we will see photoelectric effect. Now metal, how it is acting as a photoelectric cathode, that we will see. We will consider a metal. We will consider a metal. In the metal nucleus, we are considering nucleus of the metal. Then outer electron of the metal. Outer electron of the metal. So outer electron of the metal we are taking. Outer electron of the metal. This electron is outer electron. Outer electron in the sense which can involve in chemical reaction easily, and also it is free electron. Okay. Now in this metal atom, this electron is revolving around the nucleus. That means electron is revolving around the nucleus in the sense electron is under the control of nucleus, or nucleus is under the control of electron. What do we say? Electron in the metal atom, electron is revolving around the nucleus. In the metal atom, electron is revolving around the nucleus. That means this electron is under the control of nucleus, or nucleus is under the control of electron. Which one? That how to say, sir? So due to this nucleus, electron is revolving around the nucleus. Due to this nucleus, electron is revolving around the nucleus. Between this nucleus and electron, attractive force is possible. Therefore, the electron is bounded in the atom. Electron is bounded in the atom. So, why electron is bounded in the atom? Because of attraction between nucleus and this electron. Because of this positive charge and negative charge attraction. Due to attraction, electron is bounded in the atom. Electron is bounded in the atom. So, what is the force of attraction between nucleus and electron? What is the force of attraction between nucleus and electron? Here attractive force is possible. Therefore, electron is bounded. Electron is bounded. Suppose this bounding energy is, for example, 2 joule. For example, we have considered in order to understand it. Okay. So, between this electron and the nucleus, the bounding force is 2 joule. Bounding force is equal to 2 joule. So, that means this electron is around the nucleus. Why? Because nucleus is attracting this electron. So this electron is under the control of this nucleus. This electron is under the control of this nucleus. Okay. Now this electron is under the control of this nucleus means this electron is due to that this electron is revolving around the nucleus. Okay. So this electron is revolving around the nucleus because electron is under the control of this nucleus. So between nucleus and electron, attractive force is possible. So we can say this electron is bounded in the atom. This electron is bounded in the atom. So the bounding force between nucleus and electron is, for example, 2 joule. Like this we'll take. Now you say in this metal atom, this electron, can it come outside or can it be around nucleus every time? What do you say? In this metal atom, this electron, can it come outside instantly or can it be around this nucleus? Which is possible? Which is possible every time? Which is possible every time in the metal atom which is in metal lattice. Now this electron, can it be around the nucleus or can it come even outside also? Okay, it can be around the nucleus only. This electron can be around the nucleus only because of a bounding force of attraction between nucleus and electron. Sir, now we will do externally, we will do something. Now we will give radiation. Okay, externally we will give radiation. Externally we are giving radiation. Radiation consists of a quanta. Radiation consists of quanta. In that singular is quantum. We will take quantum. This quantum is having energy. This quantum is having energy. For example, this energy is this quantum is having energy. For example, this energy is equal to suppose 1 joule. The energy is equal to how much means suppose 1 joule. Okay. So 1 joule of energy is there in the quantum. This quantum falls over this electron directly. Then this electron is absorbing this quantum. So this electron has got 1 joule of energy. So this electron is getting this energy. This energy is utilized for breaking this attraction. Can we say? Or this energy is not utilized for breaking the attraction? What shall we say? Or due to this energy, this attraction magnitude increases? What shall we say? This electron is getting this much energy because of this quantum. This electron is getting this quantum. So this electron has got this energy. Due to this energy, attraction between nucleus and this electron, will it be affected or not affected? What do you say? Attraction between nucleus and electron, will it be affected or not affected? What shall we say? Affected. Okay. Between nucleus and electron, attraction is affected. Affected in the sense, shall we say, between nucleus and electron, attraction decreases. Due to this, attraction decreases, shall we say, or attraction increases, shall we say? What happens? Due to this quantum, attraction decreases. Okay. So, due to this quantum, attraction between nucleus and electron decreases. Sir. So, due to this quantum, attraction between nucleus and electron decreases, you are saying. Okay. So, because of this quantum, attraction between nucleus and electron decreases. Sir, because of this quantum, this attraction is decreases and this is becoming 1 joule. Shall we say? Attraction decreases. Attraction between nucleus and electron decreases and that is becoming 1 joule. Therefore, since attraction decreased, this attraction is decreased. So electron comes somewhat away from the nucleus. So electron is being somewhat far away from the nucleus. Shall we say? Now what happens means radiation. We are exposing this metal to radiation. This radiation contains quantum. This quantum means it is having energy, for example, 1 joule. This quantum exactly falling over this electron. This electron is observing this quantum. Due to this quantum, this attraction between nucleus and electron decreases. Therefore, this electron comes somewhat far away from the nucleus. Shall we say? This electron comes somewhat far away from the nucleus. Shall we say? This electron comes somewhat far away from the nucleus because attraction is decreased. We are saying attraction is decreased. What does it mean? Distance between nucleus and electron increased, isn't it? Attraction is decreased means the distance between nucleus and electron is increased, isn't it? Because plus charge and minus charge. Nucleus is having plus charge, electron is having minus charge. Between them attraction is possible. That attraction depends on distance. If distance between nucleus and electron is low, then attraction will be high. If attraction is low, attraction is decreased means distance between nucleus and electron is increased. That is the meaning, no? Distance between nucleus and electron is increased. Therefore, electron is coming somewhat far away from the nucleus. Electron is coming somewhere far away from the nucleus, isn't it? Sir, okay. So here we have given the radiation. Radiation consists of this quantum. This quantum is having this energy. So when the energy of quantum is this much, what had happened means attraction between nucleus and electron decreased. So electron comes somewhat far away from the nucleus. That's what we said here. Sir, okay. Now we will consider in another way now. In another way, we will consider now this one. Okay. Sorry. Now it is the nucleus of metal atom, and the outer electron is here. Outer electron is here. That outer electron is called valence electron. Between this nucleus and this outer electron, attraction is possible. Due to attraction, this outer electron is bounded in the atom. That bonding force is suppose 2 joule. Now we will expose this one to the radiation. It is this metal atom is exposed to the radiation. Radiation is falling over this metal atom. Radiation consists of quantum. Okay, this quantum is having energy. Suppose this energy is equal to 2 joule. For understanding, we are considering like this. This quantum is having energy. That energy is equal to 2 joule. Now, this quantum is falling over. This quantum is exactly falling over this electron. This electron is absorbing this quantum. So this electron has got this much energy. Now we can say this energy is utilized for decreasing the attraction, breaking the attraction. So breaking the attraction. Therefore, it is becoming 0 joule, isn't it? Isn't it? Now see, you have given the quantum. The quantum is having energy 2 joule. For example, we are considering like this in order to understand. This quantum is falling over this electron. This electron is absorbing this quantum. So this electron utilizes this energy for breaking this attraction. So this electron is utilizing this 2 joule to break this attraction. Therefore, between nucleus and electron, what is the attractive force? What is the bonding energy? That is becoming 0 joule. Now you say under this condition, between nucleus and this electron, is there any attraction? Is there any attraction between nucleus and electron? Is there any attraction? What do you say? Is there any attraction between nucleus and electron? Is there any attraction now? What do you say here? Between nucleus and electron, what is the magnitude of attraction? If attraction is there, what is the magnitude? If attraction not there, the attraction is 0, you say. Okay. What is there any attraction between nucleus and electron? What do you say? Okay. You are saying that 0 attraction. Attraction is 0. Sir. So you are saying that between nucleus and electron, attraction is 0. That means nucleus and electron, between nucleus and electron, attraction is 0 means nucleus is not attracting electron. Electron is not attracting nucleus. Why? Because distance between nucleus and electron is infinity. Distance between nucleus and electron is infinity. So that nucleus is not attracting electron and vice versa. So between nucleus and electron, there is no attraction. So electron is not under the control of nucleus. So that means, this meaning is electron is in the metal atom, or electron came out from the metal atom. What shall we say? Now there is no attraction between nucleus and electron. That means electron is not under the control of nucleus. Then can we say electron is being around the nucleus? Can we say electron being around the nucleus? Can we say electron is in the atom, metal atom? Shall we say electron is not in the metal atom? It is not under the control of metal atom. It came out from the metal atom. What shall we say? Shall we say electron is not in the metal atom? Shall we say electron came out from the metal atom? Shall we say like this? Okay. So you are saying that now what do you say, that electron came out from the metal atom, or otherwise electron is in the metal atom? You are saying that electron came out from the metal atom. Electron came out from the metal atom. Okay. So now electron is not in the metal atom. Electron came out from the metal atom. That means now photoelectric effect is possible or not possible? What do you say? That means photoelectric effect. Photoelectric effect is possible, shall we say, or not possible, shall we say, under this condition? Photoelectric effect is possible or not possible? What shall we say here? Photoelectric effect is possible or not possible? What shall we say? Photoelectric, in under this condition, when you use so and so radiation, when you use so and so radiation, when you use so and so quantum, photoelectric effect is possible or not possible? What shall we say? Shall we say photoelectric effect is possible? Shall we say photoelectric effect is possible in this case or not possible? You are saying that photoelectric effect is not possible, sir. So one student says that photoelectric effect not possible. One student says possible. Okay. Now we will see. One student says photoelectric effect not possible. First, what is meant by photoelectric effect? Photoelectric effect means the given photocathode, that means the given metal should be exposed to the radiation. On exposing to the radiation from the metal, electron should come out. That is only photoelectric effect, no? Isn't it? Photoelectric effect means what? When the metal or photocathode on exposure to radiation from the metal, electron should come outside. Electron should come out from the metal lattice. That is called the photoelectric effect. Now here you have given the radiation. That radiation contains quantum. That energy is so and so, we said. This quantum is falling over electron. Then what happened? Between nucleus and electron, distance become infinity. There is no attraction between nucleus and electron. So we said electron came out from the metal atom. Electron came out from the metal atom means that is called photoelectric effect, no? Isn't it? That is called photoelectric effect, do we say? Or that is some other? What is photoelectric effect? On exposing on the metal lattice to the radiation, electrons come out from the metal atoms. That is only photoelectric effect, no? Now what do you say? Photoelectric effect possible, shall we say, or photoelectric effect not possible, shall we say? What shall we say? Electron came out from the metal atom, that conclusion we got it. Electron came out from the metal atom, that conclusion we got it. Now shall we say this effect is called, this procedure, this, that means electron coming out from the metal atom, this process is called a photoelectric effect, shall we say, or photoelectric effect we cannot say? What shall we say? Shall we say photoelectric effect possible, sir? So we are saying a photoelectric effect is possible, sir. Okay. So if here photoelectric effect is possible, we said. Okay. Next point we will take, we will consider a nucleus of the metal atom. Nucleus of the metal atom be considered. Next we will consider outer electron of the metal atom. We are considering outer electron of the metal atom, we will consider. It is outer electron of the metal atom. Between this outer electron and nucleus, between these two, attraction is possible. Due to attraction, electron is bounded in the metal atom. This bonding force, suppose that energy is equal to 2 joule, we will take that bonding force, that energy is equal to 2 joule, we have considered. Next we are exposing this metal lattice to the radiation. This radiation consists of quantum. This radiation consists of quantum. Suppose the energy of quantum is 3 joule. Suppose energy of quantum is 3 joule. This quantum is falling over this electron. This electron is absorbing this quantum. Due to that attraction between nucleus and the electron, and attraction between nucleus and the electron is breaking. So bonding force is breaking. So bonding force breaking means now attractive force. Now attractive force between nucleus and electron, between nucleus and electron becomes 0. Attractive force between nucleus and electron becomes 0, isn't it? Attractive force between nucleus and electron becomes 0. This indicates electron, this indicates between nucleus and electron distance is infinity. Distance is infinity. Okay, that means there is no attraction between nucleus and electron. That means electron is not under the control of nucleus. Electron is not under the control of nucleus. That this indicates electron came out from the metal atom, shall we say? Electron came out from the metal atom, shall we say? Okay. If electron came out from the metal atom, then this phenomenon is called what? What phenomenon took place here? What phenomenon took place here, shall we say? Now see, here this metal is exposed to the radiation. On exposure to the radiation, electron is absorbing the quantum. Due to absorption of the quantum, the electron came out from the metal atom. Electron came out from the metal atom. Now, what phenomenon took place here? What this metal went for which process? Metal went for which process? What phenomenon took place in this case? What phenomenon took place in this case? What then? What is possible? Do you say which phenomenon possible? Which phenomenon possible? That means metal went for which process? So you are saying that photoelectric effect is possible. Okay, so photoelectric effect is possible, you said. Photoelectric effect is possible, you said. So here we are saying when the energy of quantum, here energy of quantum and attractive force magnitude, that we will see. Here energy of quantum, here energy of quantum is 3 joule. Attractive force magnitude, that attractive force magnitude, that bonding force is 2 joule. Here attraction between nucleus and electron, that bonding force is 2 joule. Quantum energy is 3 joule. Now when the energy of quantum is greater than attractive force magnitude between nucleus and electron, photoelectric effect is possible. Okay, now energy of quantum is 3 joule. Attraction between nucleus and electron, that bonding energy is 2 joule. Okay, that means energy of quantum is greater than attractive force magnitude, attractive force, that bonding force between nucleus and electron, while photoelectric effect is possible, we said. Sir, now in this case we will take here energy of quantum is 2 joule. Okay, energy of quantum is 2 joule. Energy of quantum is 2 joule. Between nucleus and electron, attractive force is there, therefore bonding force is there, that bonding force is 2 joule. Okay, bonding force between nucleus and electron, bonding force between nucleus and electron, bonding force between nucleus and electron is 2 joule. Quantum energy is 2 joule. Here energy of quantum is equal to bonding force between nucleus and electron. Here what happened? We said photoelectric effect is possible, we said. Photoelectric effect is possible, we said. So when the energy of quantum is equal to bonding energy between nucleus and electron, photoelectric effect is possible, sir. Next we will see here. In this case, energy of quantum is 1 joule. Here energy of quantum is 1 joule. Okay, here between nucleus and electron attraction is possible. That means between nucleus and electron bonding force is possible. That bonding force is 2 joule. Sorry, between nucleus and electron bonding force is possible. Now energy of quantum is 1 joule. Between nucleus and electron attraction is there. That means electron is bounded. Bounded with what energy? 2 joule. Here energy of quantum is less than bounding energy, bonding force between nucleus and electron. Now here shall we say photoelectric effect possible, shall we say, or not possible, shall we say? What do you say? Photoelectric effect is possible or not possible? What shall we say here? Okay, you are saying that photoelectric effect is not possible. Photoelectric effect is not possible. That means when the energy of quantum is less than bounding force between nucleus and electron, photoelectric effect is not possible. When the energy of quantum is equal to bounding force between nucleus and electron, photoelectric effect is possible. Sir, when the energy of quantum is greater than attractive force, that means bonding force between nucleus and electron, photoelectric effect is possible. Sir, okay. Next, we'll consider the nucleus. We'll consider the nucleus of the metal atom in the metal lattice. Then we will consider outer electron. We will consider outer electron. It is outer electron or valence electron we considered. Sorry. So we considered the valence electron. Now we will expose this electron to the quantum, to the radiation. This metal is exposed to the radiation. This metal is exposed to the radiation. This radiation consists of quantum. This radiation consists of quantum. This quantum is having energy. Energy is equal to 1 joule. Energy is equal to 1 joule. Between nucleus and electron, attractive force is possible. Due to attractive force, electron is bounded. That electron is bounded with what energy means? Suppose 2 joule. Between nucleus and electron, attractive force is possible. Therefore, electron is bounded in the metal atom. That bounding force is how much? Means 2 joule. Now, this quantum is falling over this electron. This electron is absorbing this quantum. This electron is absorbing this quantum. Here, how it is there means energy of quantum. Here, energy of quantum is less than this bounding force, between nucleus and electron. Okay. So here what happens? What is happening here? That we'll see. This electron is absorbing this quantum. Due to that, energy of electron, energy of electron increases. Energy of electron increases. Therefore, bounding force between attractive force between nucleus and electron, what happened means decreases. Attraction force decreases. Then distance between electron and nucleus and electron increases. Distance between nucleus and electron increases. Here what happens means photoelectric effect is not possible. Photoelectric effect is not possible. Photoelectric effect is not possible because electron did not come out from the metal atom. Electron did not come out from the metal atom. That we said. Sorry. Now this energy of quantum, is directly proportional to what means frequency of quantum, frequency of radiation, that we can say. This we got in Planck's quantum theory. Energy of quantum is directly proportional to frequency of radiation. Okay. Energy of quantum is directly proportional to frequency of radiation. So here in this place, the frequency of radiation is such that photoelectric effect is not possible. Here in this place, the frequency of radiation is such that photoelectric effect is not possible. Sir, okay. Photoelectric effect not possible, we said. Next, we will consider nucleus of the metal atom. We will consider. Then outer electron, nucleus of metal atom, we said. Then outer electron of the metal atom. This outer shell contains a valency electron, outer electron of the metal atom. Now, this electron is exposed to the radiation. This radiation consists of quantum. This quantum is having energy, for example, 2 joule. Between this nucleus and the electron, attractive force is possible. Due to attraction, electron is bounded in the metal atom. That bounding force, for example, 2 joule. Now, this quantum is falling over this electron. This electron is absorbing this energy. Therefore, what happens? Due to absorption, what happens? Here, in this case, energy of quantum is equal to bounding force of attraction between nucleus and electron. Therefore, what happens? This electron breaks the attraction between nucleus and electron completely. Electron is absorbing this quantum and breaks the attraction between nucleus and electron completely. It breaks. Sir, okay. For breaking, the electron utilizes quantum energy completely for breaking attraction between nucleus and electron. Sir, okay. Now, between nucleus and electron, distance is infinity. Distance is infinity. This meaning is electron came out from the metal atom. Metal atom. That's what we can say. Electron came out from the metal atom, we can say. That means here we are saying that photoelectric effect is possible. We are saying. Okay. Here energy of quantum. Here in this case, energy of quantum is directly proportional to frequency of radiation. Here frequency of radiation. In this case, the frequency of radiation is such that The frequency of radiation is such that photoelectric effect is possible. Here, frequency of radiation such that electron electron utilizes quantum energy completely for breaking attraction between nucleus and electron. That's what we said here. Sir, okay. Next, next we will take another thing. We'll consider a nucleus of metal atom. We'll consider, and outer electron of the metal atom we'll consider. We'll consider a outer electron of the metal atom or valence electron of the metal atom. We'll consider this is exposed to the radiation now. It is exposed to the radiation. This radiation consists of quantum. This quantum is having energy that is, for example, equal to 3 joule. Now, between nucleus and electron, attraction is possible. Therefore, electron is bounded in the metal atom. That bounding force is how much means? Suppose 2 joule. Now, this quantum is falling over this electron. Electron is absorbing this energy. So, what happens here? In this case, energy of quantum. In this case, we can say energy of quantum is greater than bounding force. Energy of quantum is greater than bounding force, we can say. Now, electron absorbing the quantum, electron absorbing the quantum, in that part of quantum energy, part of quantum energy is utilized for breaking attraction between nucleus and electron, between so and so. Then electron part of quantum energy part of quantum energy is with the electron. Now that energy will be in the form of what? With the electron. See, electron is absorbing this quantum. This quantum is having 3 joule. This electron is absorbing this quantum, means this electron has got this 3 joule. In this 3 joule, this electron utilizes 2 joule for attraction, for breaking this attraction. So remaining energy is there with what? What happened to the part of quantum energy? Will it be with the electron? If it is with the electron, it will be in the form of what? It will be in the form of what? What do you say? Here, in this case, energy of quantum is greater than bounding force, isn't it? Energy of quantum is greater than bounding force. This quantum is falling over this electron. Electron is absorbing this quantum. That means electron has got that energy. Electron has got that energy, isn't it? In that energy, it utilizes a part of energy for breaking this attraction, for breaking this bonding. Remaining energy is in the form of what with that electron? One student says that energy in the form of repulsion. Repulsion means who is there another in order to repel? That you think? Is there any other in order to repel? No other is there, because electron is at infinity distance from nucleus. Therefore, who is there to repel with that? One student says that that part of quantum energy is with the electron as a kinetic energy. Sorry, okay. So the quantum is having 3 joule. In this 3 joule part is utilized for breaking attraction between nucleus and electron. Remaining part is in the form of kinetic energy. Sir, in this case, electron came out from the metal atom. So photoelectric effect is possible, we are saying. Sir, now energy of quantum. Energy of quantum is directly proportional to frequency of radiation. Energy of quantum is directly proportional to frequency of radiation, we can say. Frequency of radiation. Here, the frequency of radiation is such that photoelectric effect is possible. Along with that, electron is having some kinetic energy also. Electron is having some kinetic energy also. So in this case, the radiation is having some frequency. The frequency of radiation is such that photoelectric effect is possible, as well as the came out electron is having some kinetic energy also. So the frequency of radiation is such that photoelectric effect is possible. Simultaneously, the came out electron is having even kinetic energy also. Sorry, okay. Now we will see in this case. Here energy of quantum is 2 joule. Attractive force magnitude, attractive force, that bonding force between nucleus and electron is 2 joule. Here what happened means electron utilized that quantum energy completely for breaking attraction between nucleus and electron. Here also photoelectric effect is possible. What do you say about kinetic energy of electron? What do you say about kinetic energy of electron? What do you say about kinetic energy of electron which came out from the nucleus, which came out from the metal atom? What do you say? In this case, you see that you have supplied energy of quantum is 2 joule. You supplied energy of quantum is 2 joule. Okay. This 2 joule is completely utilized for breaking this attraction. Electron came out from the metal atom. Distance between nucleus and electron is infinity. Electron came out from the metal atom. Photoelectric effect is possible. Okay. What about the came out electron kinetic energy? That is zero with respect to exposed radiation. With respect to exposed radiation. So here frequency of exposed radiation is such that photoelectric effect is possible, but kinetic energy of electron is zero. Kinetic energy of electron is zero. Sir, now we will see in this case. Here energy of quantum is 1 joule. Attractive force, bonding force between nucleus and electron is 2 joule. Here when energy of quantum is less than bonding force between nucleus and electron, what happened means photoelectric effect is not possible. So here frequency of radiation is such that photoelectric effect is not possible. Sir, so now we discussed three cases. In one case, the frequency of radiation is such that there is no photoelectric effect. It is one case we discussed. Second case we discussed the frequency of radiation is such that photoelectric effect is possible, but the came out electron is not having any kinetic energy with respect to exposed radiation. Then third case we discussed the frequency of radiation is such that photoelectric effect is possible, and the came out electron is having some kinetic energy. Like this, three cases we discussed. Three cases. One is first case, like this with three cases we discussed. Now you say which is the minimum frequency required to just photoelectric effect to possible. Out of these three, which one is the minimum frequency of radiation required to take place photoelectric effect? Now out of these three cases, which frequency of radiation, which minimum frequency of radiation is required to take place photoelectric effect, just photoelectric effect to be possible, for which what is the minimum frequency required? You are saying that second case. Therefore this is the frequency of radiation it is required just to take place photoelectric effect. In this frequency of radiation, just photoelectric effect is possible, but in this frequency of radiation photoelectric effect is possible, as well as the came out electron will have kinetic energy. In the second case, just photoelectric effect is possible. Came out electron will have zero kinetic energy with respect to exposed radiation.